Chapter 3 here has been all about logic, truth tables, things of the like. And to me, it's been a lot of fun. We looked at the basic truth table for a negation, that if you start with a statement P, when it's true, the negation's false. When it's false, the negation is true, which is exactly what you think. So the negation is just kind of like taking the opposite stance. That's all it really is at the end of the day. The conjunction, if you have two statements P and Q. Now notice we have to include, these are just our statement declarations at the beginning. We run through every possible combination of each statement being true or false together. They can both be true. First one true, second one false. First one false, second one true. Both of them false. So each row of a truth table is one state of nature, one possible state of true-false combinations between your initial statements. This is when we are actually doing like a computation or a calculation. We have the P and Q column. That's only going to be true when both pieces coming in are true. If either of them are false, if both of them are false, the P and Q column is false. The disjunction, though, the word or, that is going to be true as long as at least one of the individual statements are true. So when they're both true, the or is absolutely true. When one is true and the second one is false, you're going to have a true statement. In that case, because at least one of them was true to start with. This one was true, this one might have been false, but that's okay. You just need one or the other, or perhaps both, to be true. In this case here, in this next line, we had a false and a true, so at least one of them is true. So the or statement is true. The only way to make the or statement false is if both pieces are false themselves. Remember last time we kind of compared this to, I used like a bar example, a bar, and like an actual bar where you go to get drinks. Remember we said that, well, there are some bars, say they have a band playing tonight. Well, some bars, first of all, you have to be 21 and up in order to get in. And if they have a band playing or some kind of DJ or something, they're going to pay that band or DJ by charging you a cover fee. And if you pay that cover, that money usually goes to the band, or a portion of it does. So for that kind of scenario, the bar is only going to let you in if you are both at least 21 and willing to pay the cover. Then they'll let you in. You'll get a true statement. But if you're 21, yet you're not willing to pay the cover or don't have it, they're not going to let you in. If you're under 21, even if you're willing to pay a cover, they're not going to let you in. And then in this last case, if you're under 21 and you're not willing to pay the cover, they're definitely not going to let you in. So the and statement is kind of like that fairly exclusive bar that has two full rules that you have to follow to get in. The or statement, though, this could be a bar. There are some bars that will let you in as long as you're at least 18. You can be 18, 19, or 20. Some of y'all may have gone if you're under 21, but they won't serve you drinks. They usually they put the X's on your hand with a Sharpie. Oh, they'll like carve it in. Yeah, they're like, this person is under 21. It's because they're gonna get popped by TABC if they sell alcohol to a minor. I mean, the fees are just outlandish. So anyways, there are some bars that let you in if you're under 21, but you can just kind of sit there sipping your Shirley Temple, watching football or something. But if for that kind of bar, they'll usually have this rule. You can get in if you're over 18, but if you're at least 21, we won't charge you a cover. We won't charge you a cover fee to get in because we think you're going to spend money on drinks and we're going to make our money off you that way. If you're under 21, though, we'll still let you in, but we got to charge you $10 to get in the door because otherwise you're going to buy a Shirley Temple, and maybe some nachos or something off the menu. So that bar is a little bit less exclusive. If you are at least 21 and you're willing to pay the cover fee, Well, you don't have to pay the cover fee, but if for some, they're not going to turn away $10 that you want to throw them, they'll let you in. If you're at least 21, but you are unwilling or don't pay the cover fee, they'll still let you in because this bar is a lot easier to get into. If you're under 21, but you're willing to pay the cover fee, they'll let you in. The only way they won't let you in is if you're both under 21 and you don't have the cover fee or you don't want to pay it. They're not going to let you in that case. So this is like saying you have to be at least 21 or pay a cover fee. This is like saying you have to be at least 21 and pay a cover fee. And so using the word and, even though it's kind of opposite, when you say the word and, you think you're bringing things together, but you're actually making it more exclusive. The group is harder to be a member of. When you use or, the group is easier to be a member of. So a few quick examples. Let P and Q represent the following statements. P is the statement that 10 is greater than 4. Cool. And now, again, we're not really doing any serious math at the moment. It's just a statement 10 is greater than 4. Q is the statement 3 is less than 5. The statement P and Q is a true statement because both of the statements leading up to it are true. 10 greater than 4 is a true statement. 3 less than 5, also a true statement. Thus, this new statement, this new compound statement we're making, P and Q, is true because each of the pieces we brought into it are true. That's this line, sorry, that's the front of it. That's this line of the truth table, the top one. And there's all kinds of things you can do to mix them up. The statement not P and Q. Well, since P is true, that means not P is false. So you're taking a false statement and you're conjuncting it, anding it with a true statement. So whenever you do a false P, false first statement, but a true second statement, the whole thing is false. The cool thing is we can actually even make ourselves a truth table just for that. Truth table. Let's see if my artist skills are good enough for this. I'm going to say yes. So here's the truth table I'm going to draw. This first one was just going to be P. Then I'm going to have Q. Now, ultimately, the truth table I want to make is for not P and Q. I have to use this symbol for my and. So that's going to be the last line, or the last column. Now, we notice here, we need to always declare our initial statements, P and Q. But this final thing requires a not P, so we're going to make an extra column for not P. And now, no matter what, for this P and Q column, it's always going to look the same. You're going to do true, true. The next column, you're going to do true, false. The next column, you're going to do false, true. The last column, you're going to do false, false. You're running through every possibility. Now we'll go column by column, not P. Since P is true initially, not P is false. Since P is true here, not P is still false. Since P is false here, not P is now true. Since P is false here, not P is now true. What's that? That's the beauty of it. We don't know, whenever we're making these truth tables, we don't know yet if they're true or false statements. So instead of trying to guess, are they true or are they false, what we're going to do is just list out every possibility. We're going to list out the possibility where they both happen to be true. Then the possibility where the first one's true, but the second one's false. Then the possibility where the first one's false, but the second one's true. Then the possibility that both of them are false. Would you agree that those are the only 4 possibilities? So even if we don't know if P or Q is true yet, we can still analyze a more complicated statement like this one. Mm-hmm. Exactly. Not P is itself a new statement that is the opposite of the original P statement. So whenever the original P statement is true, the opposite of that's going to be false, and vice versa. So yeah, that's a great question. How do we know if P and Q are true or not? We actually don't always know that, but we can still make a truth table because all it's doing is highlighting all the possibilities. Does that make sense? So now finally we're ready to do it. We're ready to get the last column. And now we want not P, which is this one here. Well, let's not use red. We're going to conjunct it. We're going to do the and with this column here, the Q column. So for this last column, we're ignoring P because P is just not necessarily part of the process anymore. So I'm doing the and statement between this and this here. I'm doing not P and Q. The only way this will be true is if both of the individual pieces coming into it are true. But this is false, this is true. Thus, this is a false statement because both pieces have to be true for the and statement to be true. This is extra false because they're both false. This is going to be a true statement because both of the pieces going into it are themselves true. This last one, though, will be a false statement because one of them is false. One of them rings false. Mm-hmm. Did it? Well, you can help her this week, can't you? You say, hey, now I can help you. Now I'm an expert at this. And that's a great point because, like I said, this doesn't look like math. Mm-hmm. Yeah. Yeah, the set theory doesn't look like math, and this logic crap doesn't look like math. It's not. But it's actually, not only is it math, this is math in like its purest form. We think of math as just numbers and calculations and stuff. And while there's truth to that, the numbers and calculations kind of come after we establish the logical structure of mathematics, which is what kind of one of the things we're doing here. Once you've established the logical structure, which is a lot harder than just adding crap together. This is much more abstract and harder to put your mind around. But once you do it, then numbers and calculations become, I don't want to say easy, but you kind of see how there's more difficult math out there that requires just like a different style of thinking. Exactly. You would say not P, and we always know that the negation sign here, this squiggly line, goes immediately just to the first thing. We're not saying that we're taking the opposite of the P and Q statement by putting parentheses around it. That's different. When we don't have parentheses, the not only goes to the P, and then it's a new day and we do the and with Q. So now going back to what we were looking at in the PowerPoint, notice here that we started with the statements P, 10 is greater than 4. Well, this is a true statement. This second statement, Q, 3 is less than 5, also happens to be a true statement. So we have made the full truth table that kind of highlights all the possible combinations of true and false for P and Q. But now we actually know what P and Q are. We can see these are clearly true statements. Thus, when we go back to the truth table for it, we're not looking at every possible row. Let me get rid of this. No. Okay. All right. Well, scratch that. But we're not looking now at every row. We're looking at the row that starts off with P and Q being true statements because that's what we start with here. P and Q are true statements, and we can verify that using other reasoning. So now we are focused in just on this row here. And our final conclusion is that not P and Q is a false statement. Hence, I can say that not P and Q is a false statement. In English, in English, not P and Q is the statement. And it's going to be kind of wordy. It is not the case that 10 is greater than 4 and 3 is less than 5. That's the English translation given what P and Q are at the beginning. Not P and Q. It is not the case that 10 is greater than 4. So we are taking the opposite of P by saying that. And also 3 is less than 5. But we can clearly see that that's a wrong statement. It's not the case that 10 is greater than 4 and also 3 is less than 5. No, it is absolutely the case. Both 10 is greater than 4 and also 3 is less than 5. So somewhere this statement that we've created, this compound statement, falls apart and is illogical. Using the same P and Q, now we can make the OR statement. P is still the statement 10 greater than 4. Q is still the statement 3 less than 5. The statement P or not Q. When P is true, as long as at least one of these two statements is true, the OR between them is going to be true. So P is already a true statement. I'm going to give myself a little space. P is already a true statement. We are taking the opposite of Q. So since Q starts off true, what we're really doing, brass tacks, is we are doing a true statement, P. We're ORing it with a false statement because not Q must be false since Q is true. And when you do the OR with a true and a false, well, as long as at least one of them is true, the entire statement becomes true. That's kind of what's going on here. The truth table lets us just review it for every possible combination of P and Q. So I'll go ahead and make an entire truth table for this, not P or not Q. Let's do it. And now I'm going to intelligently just use, well, I can even leave that. I'm going to try and, wait a minute, you quit that. Well, I guess I could use some other techniques. I'm going to create this truth table here, but it's kind of a pain writing out the table. So all I got to do is add one more to it. And then you will see my witchcraft at work. My witchcraft is not very strong today. All right, fine. Make me do it the hard way. Okay, so we're just going to add one more column onto here. So the statement we're going to make a truth table for now is going to be this statement. Not P or, and I'll put a little space here, or not Q. So in order to make this, the final statement is always going to be what's in the last column. So the thing we're trying to make a truth table for, not P or not Q, is going to go at the end here. In order to do it, I'm going to need a not P column and a not Q column. The idea is that each row, each column of the table, I only want to ever have to do one computation. I don't want to have to both do a not P computation at the same time I'm doing an OR computation at the same time I'm doing a not Q computation. That's just a pain in the butt. Now, maybe later on, as you get more comfortable with these, you can do that. But for now, we're going to break it down piece by piece. So no matter what, these first two columns, we just have to declare all the possibilities between P and Q. They can both be true, first one true, second false, and so on. Now we know the rest of the columns we have to fill in here. Let's see, we need a not P column, so just take the opposite of the P column. So that's false, false, true, true. Now for the not Q column, ignore everything else except the Q column and just take the opposite of the Q column. So that's going to be false, true. She loves me not. So again, we're just doing one computation at a time. Finally, we're doing the OR between not P as well as not Q. We're taking the OR between them. So all I'm looking at are these two columns now. P and Q did their service, and now we can take it over with the not P, not Q column. The OR is going to be true as long as at least one of the contributing pieces is true. But here they're both false, so this one is false. And I'll even, actually, this is one of the major strengths of using Zoom, is because I can really use colors and all kinds of stuff like that. Okay, next up, we have a false statement. We're doing the OR, the disjunction, with a true statement. Well, at least one of them is true, thus this is true. Here we're doing a disjunction between a true statement and a false statement, which is going to be true because at least one of them is true. Here we're doing the disjunction between two true statements. Since at least one of them is true, this is going to end up being true as well. Exactly. That's why and it's harder to get a true statement out of the and statement because you got to have everything true in there. The or statement is a little more lax. It's like Matthew McConaughey. It's just like, yeah, whatever. As long as at least one of you is true, then I'm good. I was driving a Lincoln long before they paid me to drive a Lincoln. So this would be the final column, if you will. So I'm going to erase this little green box, and that might screw things up. Of course it did, because nothing, every rose has its thorn. This ended up being true. Okay. So now we've gotten all the possibilities here for the not P or not Q column. So now let's go all the way back to our PowerPoint. All right, for not P, not Q, now we are in the state of nature now that we've defined what P and Q are. The truth tables for, in general, when you don't know what P and Q are, that's okay, you can still generate the truth table. But in this particular case, we have two statements, P and Q, that are both true. It's T for P and T for Q. So we can go back to the truth table, and now I know, oh, well, I need the state of nature where both my statements are true to start with. Ah, that's this row here, because both P and Q are true. So I'm going to highlight this row. I'm going to go to my very last entry because that's what we're trying to get at, and it's false. So when P is true, Q is true, the statement not P or not Q is actually false, according to all this computation stuff we did. So this ends up being, we can say, this ends up being a false statement. Oh. That's how it works. It's kind of a pain, but it's actually kind of fun as well. Fun if you use the word fun loosely. If you want this statement in English, this is the statement, it is not the case that 10 is greater than 4 or that 3 is not less than 5. You could even say it even more succinctly. You can say 10 is not less than 4, or 3 is not less than 5. One of those two things has to be true, but wait a minute, 10 is not less than 4, wait a minute, that's a false statement. 3 is not less than 5, that's a false statement. So I'm saying one of these has to be true, but since they're both false, the whole thing is false. So a teensy bit confusing, perchance, but it's kind of fun as well. So we've already gotten a taste of how we can construct truth tables. If you're only dealing with two simple statements to start with, P and Q, then you have to declare all their possible truth value combinations. Again, it doesn't matter whether P or Q is true or false. You can verify that separately and then come in and pick the right row for that. So if I wanted to construct a truth table for the statement not, and then in parentheses, P and Q. If I want to construct a truth table for that, well, I got to take it one computation at a time. Since the P and Q is in parentheses, it says do P and Q first. If this did not have parentheses, remember that not would actually only apply to the P. But since there were parentheses, the not actually applies to the entire statement P and Q. Thus, we're doing the statement P and Q first. So go ahead and compute that bad boy. Then go on down the line and do another line. Do another line for not the statement P and Q. Well, since we already have a line for the statement P and Q, the not of P and Q would just be to take the opposite stance in each case. So if P and Q is true, not P and Q is false. If P and Q is false, not P and Q is true, and so on and so on. You take it step by step, not the TGIF show. For example, if we started off with the statement, Harvard is a college, yeah, that's true. Yale is a college, yeah, that's true. The statement not P and Q would be equivalent in English to, it is not true that Harvard and Yale are colleges. Well, that's clearly just kind of silly, but that applies to this line of the truth table because what we started with, P and Q, were both truths. So we go along this row of the table. This is our final kind of thing, and it's a false statement. This little question down here, is this a tautology? They just kind of dropped that one on you, but a tautology is kind of fun. When I was in high school, when I used to teach high school, I taught ology. And that joke doesn't work. Also, I've never taught high school before, just because they would kick me out of the school for being too funny. They would say, "Mr. Gunther, all you do is you make the kids just laugh so much, and you've brought so much joy to their hearts. And this is high school where they're not allowed to be happy, so we have to kick you out of here." But in college, they let me do that just fine. So college is a lot different than high school. It's harder, but you get to be a little bit more yourself. You've grown into an adult, and they're like, we don't, as long as you're not like coming to school not wearing any clothes or something, you can express yourself however you want, and that's great. That's what I like about college. So a tautology is going to be a logical statement that is always, as in Severus Snape, always true. Always true, meaning that, so this is a statement here, the statement not P and Q. This is a statement, but it would have to always be true. The entire column would have to be filled with T's, but there's an F there. So this one just kind of gives you a tease. It's not fully true in all four cases. So this is not a tautology here. There's some trivially easy tautologies that we could make. I won't spend too much time on it, but tautologies are really interesting in logic. I don't think there's a special word for a column that has all false statements in it. It's always false. A lie or just nonsense or something like that, perhaps. So tautology. What if you wanted to construct a truth table for this nasty business? The statement not P or Q, then we know that's taken together, and conjuncted with the statement not Q. Well, golly, we've got a lot of kind of individual pieces flying around here. We've got a not P, so I've got to make a not P column. We've got a not Q, so I got to make a not Q column. Do I have to do it over here? You can. We're just kind of expanding it piece by piece. We've got the computation not P or Q, and that's not even the overall computation. The overall computation is to also do an and. So we're going to save that one for last. We're going to construct it of each of its individual pieces. Then we're going to do the entire computation. Let's go through this one together. Let's do this one together. And you know what? Dun! You don't get anything special now. I might have to use the meta tool here. Okay, so no matter what, we got to start off with our declarations. Notice they don't even, in their truth tables, they don't even draw a line between them. They call this like one column almost. It doesn't really matter. That's semantics. So we got to start with our declarations. Both can be true. And no matter what, I would just remember the order. The first one true, the second one false. The first one false, the second one true. And then the last one, both false. Now, the next computation we should do is the not P computation. So just take the opposite of the P column. So it's TTFF, ta-ta for now. Now we're going to do the opposite, F, F, TT. The next computation we should probably do is not P or Q. So we are doing the not P column. We are disjuncting it. We are doing the or with the Q column. So these are the two we're looking at, right? Shmia. Well, let's not use green. Let's use blue. Because if I was green, I would die. We are doing the or between not P or Q. So let's take it piece by piece. Not P or Q, as long as at least one of them is true, this will be a true statement. So the Q is true here, so this is a true statement. Here they're both false, so the or between them is false. Here they're both true, so the or between them is definitely true. Here one is true, which is good enough for me. I don't care what the other one is. That's actually a useful logical trick. If you are taking the or of two statements and you only know the truth value of one of them, but if it's true, the or statement's automatically true no matter what you like. If it's false, the and statement is automatically false. Those are actually useful little logical tricks if you are missing certain pieces of information or are unable to assess the truth value of certain things. Okay, so we've done this one. Now we need to do the not Q column. So we just need to take the opposite of the Q column. Why are you not selecting another tool? Oh, that's why. So we take the Q column and take its opposite. So we're going to have, let's see, Q is true, false, true, false. So we're going to have false, true, false, true. And I'm slowing down and taking my time on these because these truth tables are really interesting and really important. This is the foundation of all logic. Logic is the foundation of mathematics. Finally, we're ready to tackle the entire statement. We have put it together piece by piece. We are doing the statement not P or Q. We're doing this column. We are anding it. We are taking the conjunction with the not Q column here. So these are the two columns we're zooming in on. And remember, the computation is the and. We are taking the and of this with this. The only way you're going to produce a true statement out of that is if both of the individual pieces are true. Well, we're doing the and of a true statement and a false statement, so this is going to be false. We're doing the and of a false statement with a true statement, so this is going to be false. We're doing the and with a true statement and a false statement, so this is going to be false. Finally, and now it could be possible that all of these ended up false. It just depends on what you have. But just so happens these two end up being true together, so this statement is true. So there's a couple ways to think about this. If you ever wanted a statement like this to be true, not P or Q and not Q, if you want a statement like that to be true, the only way this entire statement is going to be true is if both the P and Q original statements are false, which is kind of weird. It's kind of weird to think about it in that terms, but you kind of see there's not P's and not Q's going on. So it kind of creates a weird possibility like that. So these truth tables are pretty gosh darn interesting, if you ask me. Where's mine? There it is. You put it back. There we go. Ta-da, magique. Uh-oh. What do they say? What they say? Uh-oh, and then it's that pasta stuff you can get in a can. What is it? Uh-oh, Chef Boyardee ravioli. Is it the Great Value brand? I'm sure Great Value has a brand. And I'm sure it's not very good. I like some Great Value stuff, especially because it's a pretty. I wouldn't call it a great value. It's a pretty gosh darn good value. It's not the best value there is. What if we have a third simple statement that we bring into the mix, or? If we do that, we've created a whole new realm of possibilities. Now we can have where all three statements are true, but then you can have the case where only the first two statements are true, the third one's false. Then you can have the middle statement's false, but the other are true, and so on. We've now created 8 possibilities. So by adding another statement into the mix, another simple statement, you actually double the number of combinations. If I added a fourth statement into the mix, S, that would make it go from 8 to 16 rows, which starts to get a little bit out of hand. So anywho, that's going to be how we're doing it. Now, again, this is an ordering you might want to remember, but notice, whoops. Notice here, this pattern just repeats itself. TT, TF, FT, FF. Just like we did over here. TT, TF, FT, FF. TT, TF, FT, FF. TT, TT, TF, FT, FF. And then so we just repeat it twice, and then for the P's, we just do all T's, then all F's. It's functional, it works, it'll get the job done. And it's good to remember that because it can be hard to remember what are all the possibilities where any two of them are true. Oh, it's this one, and this one. What are the number of possibilities where any one of them is true? It's this one, and this one. It can be kind of hard to get a good idea for what order you should be writing stuff in. So what we're going to do is we're going to construct ourselves a truth table. We're going to construct a truth table for the following statement. I study hard and I ace the final, comma, or I fail the course. That sounds like a reasonable statement. Yeah, you got to study hard, you got to do well in the final, or you're going to fail, unless you're just, really gifted at whatever subject you're studying. And so maybe you've had a friend before who is just really good at math, or maybe you're really good at math, and they just come in, they breeze through the math class. They never seem to put a ton of time in because it just kind of clicks with them. Well, that's great, but we're not all like that. But maybe you're really good at English. Maybe you're really good at, I don't know what the other subjects are, history, science. Yeah, you're good at science, chemistry, biology, physics. Those are the only three kinds of sciences. So maybe you're good at something else. So at some point, your natural strengths are going to come through. If none of your natural strengths seem to align with any of your coursework, well, maybe you should look at all the paths you have. I'm not saying college isn't for you. I'm saying maybe some colleges, or maybe certain classes, or maybe you're in the wrong major in college. You should pick a different major so you can take courses that you enjoy. Of course, you kind of have to have marketable skills when you do get out of college, because you're usually going to college for a job. You want to get that job, you want to make that money. And I've said this before, but making money is the most important thing in the universe. That's not true. I'm kidding. Anywho, so let's start with this. I study hard and I ace the final, or I fail the course. We've got three different concepts floating around: the idea of studying hard, the idea of acing the final, the idea of failing the course. Thus, you can say that there's three kind of elementary, simple statements here. I study hard. I ace the final, do really well on it. I fail the course. So let's look at that first one. I study hard and ace the final. Since there's a comma, that means I need to kind of put studying hard and acing the final together. I need to and them, the word and is in there, and I'm going to put them in parentheses so that I can tell that those two belong together. Comma, or I fail the course. If I had deleted that comma, the statement actually becomes kind of ambiguous, and it's not exactly easy to read. I would just read it from left to right, but that's without anything else. Thus, this becomes the statement in parentheses, P and Q, out of parentheses, or R. And here's what the truth table is going to look like for that. P and Q or R. So you can have all T's, TTF, TFT, TFF, etc. The P and Q statement is only true when the statements P and Q are both true. So that's the case here, here, and then nowhere else. So it's only true, true, and then all falses down the line. Then we take this column here, we OR it with the R column. That's what they were doing. So a true or true statement is true. A false or true statement is still true. A true or false statement is still true. Two false statements, though, is going to be a false statement when you OR them, and so on and so forth down the line. So let's go another level with this. Remember, P was the statement, I study hard. Q was the statement, I ace the final. R was the statement, I fail the course. Let's say that you're going to go ahead and you're going to study hard. So it's a true statement. P is going to be true. Let's say, though, you're not going to end up acing the final. You didn't quite do as hot as you wanted on it. So that's false. And then let's say I fail the course. Yeah, you're going to fail the course. True. Let's say all those three things actually ended up happening, or that's what you expect to happen. So we need to look at the TFT row. Let's see, TFT. It's the third row here. So now the entire statement, I study hard and ace the final, or I fail the course, is going to be true in the particular case where you do study, but you don't ace the final, then yeah, it's true. You're going to end up failing. That's kind of what's going on here. So what we do is we make the truth table. This is for every possible combination, but then, oh wait, our PQRs, they are false, false, and true. So then the final statement must be a true statement, just reading it off of the truth table. Mm-hmm. You're just looking at all the letters before and well, I see what you're saying. Yeah, exactly. Yep. Yeah, that's exactly right. You're looking at these two columns here. Where is it? You're looking at these two columns here to figure out your last column. Because you're taking the P and Q statement, this column, you're disjuncting it, you're doing the OR with the R column here. And so you're looking T or T, that's true. F or F, that ends up being false. Because at least one of these two needs to be true in order for the OR statement between them to be true. And yeah, it's hard to see. Let's see. Let's zoomify. Computer, zoom in. Okay, Joshua. There we go. And now we can say we're looking at these two columns here. So, yep, it's kind of tough. It ain't easy. It ain't always fun. So what we kind of are saying here, there's specific cases, and what they mean is you've made the truth table. Now you're ready to actually do something with it. You made the truth table, but now you have a specific case where, P is false, Q is false, but R is true. So you need to look at the FFT row of your table and go figure out what the final conclusion is. So that's all that's saying. This is kind of a weird problem. Determining the truth value of a compound statement. The bar graph shows the distribution of looks, okay, for American men and women, ranging from homely, which is kind of a mean thing to call someone. You're awfully homely, you know that? It's like, oh, thank you. To strikingly attractive. This is weird. Okay. You're homely, you're plain. Average, most people are probably going to fall into the average category, but then you have some good looking, and then you have in the last column, I'm supposed to make the joke, that's me, I'm strikingly attractive, but I'm not going to make that joke, that's corny. Yeah, that last one, only 2% of men are considered strikingly attractive, 3% of women. Again, kind of a weird, this has to be based on survey data. So you can use that column, you can use this to make this statement. It is not true that 1% of American men are homely and more than half are average. Or it is not true that 5% of American women are strikingly attractive. Boy, okay. So first thing you're going to want to do is you're going to want to break this thing down into the 3 different concepts floating around. You have the 1% of American men are homely. You have another one that more than half of American men are average. That's a separate statement from that. It's still involving the American men, but it's a different sentiment than the previous. The last statement discusses what percent of American women are strikingly attractive. Okay, and we were just talking about Matt, then you had to go make it about looks. Yeah, I guess this problem decided to do that. Rude. Anywho, so we have 3 different statements, basic statements coming out of that. 1% of American men are homely. More than half of American men are average. 5% of American women are strikingly attractive. Then what we need to do is we need to take this compound statement. Notice there's a comma here. So that means everything that comes before is kind of going to be in its own parentheses. It is not true that 1% of American men are homely. So it's going to be not P and Q in this case. The not applies to all of this thing before here. So there's a big fat not in front of this whole first statement. So from English into logic-ese, that statement translates into this, where P, Q, and R are written like this. Now, what we have, P is the statement, 1% of American men are homely. Well, let's go back to the graph. And yeah, that's true. According to this graph, we're just going to assume it's true. So the original P we have, we're starting with, is a true statement. The Q statement, more than half of American men are average looking. Well, here's average looking. You got 59%, but more than half are average. So 59% of men are average looking. That's more than half of them. So then Q is a true statement. Finally, the statement 5% of American women are strikingly attractive. That's only 3%. It's not 5%. So the statement R is false. That's a false statement. So you could make an entire truth table. This is the logical form of it. You could make an entire 8-row truth table where you got to do P and Q columns. You have to do a not R column. You're going to have to do not this column or that. Or you can just pretend like you're doing just a single row of the column and follow your quote unquote order of operations appropriately. So since P is a true statement, Q is a true statement, R is a false statement, you can just substitute their truth values directly in for them. P is true, so I'm going to put a T in for P. It's just like substituting numbers in for variables. Q is also true, so I'm going to put a T in for Q. R, though, is a false statement, so I'm going to put an F in for that. But then I still have the not in front of it. So now I'm going to go piece by piece. The first thing I need to do is the T and T statement, not the channel, and it's got parentheses around it. So a true statement and a true statement is a true statement. There's still the not in front of it, but that's okay. We'll deal with that in a second. Then we just write the rest, or not F. So now we've got it down to here. Now we can apply the actual nots. Not T, we can also apply the not F. So that's going to flip-flop their values. So now we're just down to a false or a true statement. And since at least one of them is true, the entire statement is true. So whatever the statement was, this nasty one then ends up being a true statement. Okay, I'm going to take attendance and then we'll take our 15-minute break while I go get myself an energy beverage, because everybody needs to pick me up. Well, that's yeah, aspartame. I've heard though that aspartame, like they did that study on rats where they gave them a lot of aspartame, and it caused, I think it caused like severe brain trauma and damage to their brains. But they had to give them so much aspartame that the equivalent amount for a human being would be like you eating an entire truckload of aspartame every single week, which, but that might mean that just small little bits of aspartame aren't going to kill you. They're not going to do a whole lot. But I think the real reason you should have sugary beverages. Ugh, that's gross. Splenda is gross. So we're just talking about carbs here. We're ready to move on to chapter 8. So we just finished chapter 3, which is like the logic chapter. Chapter 8 is going to concern itself with something that is really, really, really interesting to me. I love chapter 8 because, in a nutshell, chapter 8 is all about money. Do I love money? I wouldn't say I love money, but I do love, you love seeing the money move around between your accounts. If you're putting it into savings, or if you're investing money, or if you have a retirement account with a business. Now, a lot of you are probably may not have that yet. And there's no worries about that. You're in school. The idea is you want to go to school so you can get a better job than you have now, or so you can get a good job someday if you're not working yet. That's pretty much got to be why you're here, I'm imagining. I know that's why I went to school. And when you do get to that kind of dream job, or that job where you're making the amount of money you need to live on, a lot of companies, when you're working full time with them, will offer you something called retirement matching, where up to a certain percent of your income, if you choose to save your income in a retirement fund, they will match it out of their own money, and they will not take it out of the income they're already paying you. So for instance, if however much money you make a month, if you put $500 of that into retirement, they are going to take your company their own separate $500 and put it into your retirement account that you're going to get one day to actually spend with and live on when you're ready to retire. They're taking that out of their own funds separately from what they're already paying you as an employee, your wages. So that's called a benefit. There's a lot of benefits. Some of the benefits we think of are health insurance. Your company might give you health insurance. They might give you dental insurance. But a major benefit is also that retirement matching. We're going to talk about that kind of stuff. If you're putting twice as much money into the retirement account, that's better. That's always better. Now, there's a lot of rules. Some companies will only match 50% of what you put in. So if you put 500 in, your company might only put 250 in for you. But I would still take advantage of that. Oh yeah, you save every penny you can for retirement. And if what you're going to do is you're going to take that money, you're going to invest it into an account. Usually you're going to let someone else handle the physical investing side for you. But when you invest it in that account, they're going to go put it out in the stock market, and they're going to send not just the stock market, but they're going to send your money out there to go meet some of its friends and bring its friends back to you and bring you some more money into it. It turns out there's all kinds of situations where if you worked for 40 years, you saved up every month. Let's say you put $500 a month aside every month. Well, I can actually do some calculations with you. And this is just a little side note, but this is going to really drive home why we need to learn the math in this chapter. So let's say you save $500 per month for retirement. Let's say you don't invest it and you don't take advantage of your company's matching benefits, meaning your company's not throwing in an extra $500 a month for you. It's just your 500 and nothing else. After, say, 40 years of working, or maybe 30 years, whatever you're planning to work, you'll have, well, $500 a month times 12 months per year times 40 total years. You can use a calculator. You can use a calculator for everything in this course. Don't forget that. You're going to end up with $240,000. But I'm going to tell you right now, $240,000 in terms of you're retiring and you're not working and bringing in an income anymore, that's not going to get you far. You may not even live 2 years off that, because in 40 years, is 240 grand going to go as far then as it does today? No, we have inflation. In 40 years, that 240 grand in today's money may only be worth roughly $100,000 in today's terms. It's still $240,000, but it doesn't have as much buying power as it did before. Rents are going to go up over that time. Costs of everything are going to increase so much that 240. What's that? Property tax goes up. Absolutely. It's going to eat away. You might have 2 years to live on that money. So it's not going to do much for you. But if you invest your money, now we're going to look at these formulas later on in the semester. We're going to look at them. For now, though, I don't want to put the formula out there and I don't want to scare you. If instead of just say putting that $500 a month under your mattress, which is just a term that means you put the $500 a month into an account that's not getting any interest, it's not being invested and growing. It's just straight up $500 a month. If instead you had put $500 per month in, hold on, that's not right. Number of periods. That's also not right. Interest per year. Hold on, this one wants to use a really weird. Okay. So that's one possibility. You can end up with $240,000. Great. But let's say you do the smart thing. Let's say instead you take that same $500 per month. In other words, you are making no difference in the amount that you're saving each month. You're not having to change your lifestyle at all in this second case, but you just make two different decisions with it. You take that same $500 a month and you invest it in the market, and you also take advantage of your company's matching benefit. So really, $1,000 per month is going into your account and it's growing because it's invested. If you do that and can achieve an 8% return every year, whatever you started with at the beginning of the year, you're going to have 8% more than that at the end of the year. If you can get an 8% return on that money, you'll end up with, oh my goodness, $3,491,048.25. Wow. That's a lot more money. And you didn't do anything different in terms of the amount of sacrifice you had to make each month in order to save. Either way, it's $500 coming out of your pocket every month. This second method doesn't require you to make any extra sacrifices, anything different. It's just you're letting your company match and you're getting a decent return. 8% is pretty good. 7 to 8% is about average if you invest aggressively. The point is, yeah, you want to do those things. Oh, but Josh, right when COVID hit, all the markets took a big hit and everyone lost money. Yeah, but guess what? Most people have gained that money back because investors have figured out new things to invest in thanks to our new COVID world. Whenever the government announces a stimulus plan and it comes out, that usually has a nice little uptick in the stock market, things like that. And so while you may not get 8% if you're just looking at one specific year, maybe this year your investments lost 5%, but next year they might gain 15% and make up that ground back to you. So the whole point is, this is very real. This is real math at work here. And it's saying, yeah, go invest that money and go take advantage of your company's their matching benefit. Absolutely. We're going to learn the formulas that govern everything I just did here. We're going to learn the formula for calculating that second thing. And when you understand the formulas, it's going to make it so much better for us and really kind of hit home what we're doing. We got to start with the basics though. Percent, sales tax, and discounts. Hey, here's some good news. You guys want to hear the good news? Good news. We did all of this in the 0332 course. We did all of this, every bit of it. You better believe it. We did all of this in the 0332 course, except we didn't use a calculator back then. Do you get to use a calculator in this course? Thank the maker, you absolutely get to use a calculator. So Madeline is very excited, and Madeline has every reason to be excited because now we're really just going to do a lot of this with the calculator. Now, I know what you're thinking. You're thinking, yay, and yes, it does sound nice. But secretly, deep down in my heart, I know that the calculator, believe it or not, handicaps you more than you think. I know it sounds good. It does. It absolutely. Uh huh. Uh huh. Absolutely. Yeah. Everything you remember from math before the calculator and all the math you're supposed to be learning now completely is wiped away by the calculator because it's doing the work for you. You can do even more with graphic calculators. So the yeah, and then it's like the first hit is free, right? And then you have to pay for it after that. So yeah, they take the calculator back. The calculator is a handicap, more than you want to believe. But I won't go on my soapbox here. The reason we have to give you a calculator in this course is because there are certain computations we're going to do that you literally can't do without a calculator. They're literally impossible to do by hand, in a reasonable time frame. It could take 3 hours to do a single calculation, and it's like, no, that's obviously ridiculous. So because you're allowed to use a calculator in general, you can use one here for this percent business, especially because you've learned it already without the calculator, the theory behind it. Now, this first exam here that you're taking on Thursday, remember, first of all, we're not meeting Thursday. We don't ever meet on exam days. But second of all, this first exam you're going to take here, you can have your calculator out. It's not going to help. Very little. Maybe 1 or 2 problems will actually meet it. But in reality, most of chapters 2 and 3 is just a calculator is not going to help you because you're doing set theory and you're doing logic. And that's just not very calculated. How many questions? About the same as the past couple. It's going to be on MyLabs Plus, so I would envision 20 to 25 questions. So we will use a calculator for what we're about to do here. And that's going to make life so much easier. Heck, okay, we're using a calculator. Good news, because, let's see, does this have a built-in calculator in Zoom? It does not look like it does. Well, if you had to express 5/8 as a percent, well, just do 5 divided by 8. Now, without a calculator, you got to do the long division. 8 divided into 5. You got to figure out it's 0.625. Then you got to multiply by 100, move the decimal place, and you'll end up with 62.5%. With the calculator, you can do that in 2 quick steps. Do 5 divided by 8, hit enter. Do times 100, hit enter, and that should take you to 62.5%. The calculator is easy. In fact, we've already gone over all this. We know how to convert between decimals and percents. We know how to go from percents to decimals. We know how to go from fractions to decimals, decimals to fractions, fractions to percents, percents to fractions. We've gone over all of this. Look, we've gone over the percent formula. A is P percent of B. We've done all of this, so I won't go wild with rehashing all of it. I will not go too wild with it. Let's just look at some quick examples. Suppose that the local sales tax rate is 7.5% and you purchase a bicycle for $894. That better be a really nice bike. Because if you're dropping almost $1,000 on a bike, it better be like a flying bike or something, which patent pending, I'm working on one. So you want to figure out how much tax you're paying. You just need to take 7.5% of 894. You need to convert 7.5% into the decimal 0.075 and then multiply it by 894. And then if you need to round, if you're talking about money, round to 2 decimal places unless it says otherwise. Because rounding to 2 decimal places is really rounding to the nearest cent. So you're spending $67.05 just on the sales tax. Now, the sales tax is money going to the government. Your total cost, well, take the $894, add on the sales tax. In total, the actual amount of money leaving your pocket is $961.05. So again, you're going to go home with a flying bicycle, which is pretty cool. It better fly and charge your phone while you're on it. One thing I will say is sales tax. Sales tax is really nifty. There's what a tax really is it's nothing more than a method for the government to raise money. And then the government uses that money for various things. Now, everyone disagrees on what the government should use that money for. Everyone has at least one spending policy they don't like. I won't go into the details, but taxes are nothing more than the government raising revenue by taxing you. Sales tax usually goes to the state. Sales tax is one of the major ways that the state, like the state of Texas or the state of Illinois, that it raises revenue. That's why different states will have different sales tax, because some states will just charge less than others. Texas, we have an 8.25% sales tax on most goods. Did you know when you go to the grocery store, you're usually not taxed on actual groceries, on physical food. You're only taxed on like if you buy electronics at the Walmart, or if you buy that $894 bike at the Walmart, you're taxed on those things, but usually you're not taxed on groceries because that's considered a basic necessity. And that's something I didn't even know until fairly recently. I just never really looked closely at a receipt. But that's pretty cool. So there's 3 levels of government. You have state government. They usually raise their money with sales tax. They also do the lottery. The lottery, which you might think isn't that gambling? Or the lottery is actually usually put on by the state. Not every lottery, but literally all the lottery is doing is saying, okay, we're going to issue lottery tickets. The idea is that we've got $100 million we've raised by selling lottery tickets, and we're only giving out like a $60 million lottery prize. So the government profits $40 million off that little setup, which is, I mean, that's smart for the lottery to do. So the lottery is usually put on by the government. It doesn't usually say, ooh, this is the state of Texas lottery, or it'll say that, but you don't think it's the government. You just think it's a Texas lottery only. But it is the government that's putting that on, which is kind of wild. You're like, the government says it's okay to gamble? Well, in that case, it does. And then some states also have state income tax, where the state itself will take a % of your income. But Texas does not have a state income tax. And a lot of people really enjoy living in Texas because of that. Another level of government, smaller than the state, your local government, your local city or your county that you live in, they usually raise money using property tax, meaning if you own property, land and a house, then whatever your property is worth, they will charge you a small % of that in taxes every year. If you own, let's say, like a $300,000 house, your property tax alone in Tarrant County is going to run you about $600 to $700 a month just for property tax, which means that's what a lot of people pay just in rent. And they're charging you that just in property tax. So owning a house is not cheap. It's expensive because you got to pay that property tax. If you're just renting, you're not directly paying that property tax, although the money you're paying in rent, the people who own whatever you're renting are paying property tax. In Parker County here, like in Weatherford, property tax is a lot lower. If you own a $300,000 house, you're probably looking at anywhere from $400 to $450 a month in property tax. So it is cheaper to live in Parker County than Tarrant County. Finally, the national government, the national overall government, they primarily raise their taxes through just your national income tax. That's what everyone who works in America, you actually pay some kind of income tax in most cases. So we're going to actually get into income tax in the next section here. We just kind of have to slog our way through some of this stuff that we already covered in 0332. You want to take a 15% off a computer? You're spending $14.60 on a computer. That's 15% off. Well, take 15% of $14.60, which is $219. That's the discount amount. That's how much money you're saving through this special sale. But then you need to subtract that $219 off of the $14.60, and so the price you're really paying on the computer is $1,241. As a lot of you know, Black Friday is coming up. It's the day after Thanksgiving. And man, you're going to get all kinds of discounts. If you need a new computer, a new laptop, you should really, if you have the money, if you're able to do it or willing to do it, you should maybe see if you can find some deals on Black Friday. You can get 50, 60, 70, 80% off on Black Friday. My laptop here that I'm using, I got it for like 75% off. And I was like, heck yeah, I'll take that. I even said the word heck, and someone looked at me and said, why'd you say heck? We don't allow swear words in this store. And I say, oh gosh, darn it, I'm sorry. What's that? It's fun. This year, the actual physical stores probably aren't going to be super busy. Some stores are only open on the Friday itself. They're not doing that open at 3 o'clock on Thanksgiving business. Yeah, they can only allow so many people in the store because you have to social distance and all that. It does. Everyone's supposed to run in there with pitchforks and fight each other for the 2 computers. Yeah, I've been to Black Friday the past couple years, and I usually do my shopping online, but I decided to go in because I hang out with my cousins after Thanksgiving. We're all adults. We drive around. We just do it because it's fun. And it's not been super busy the last couple of years. Online sales are really taking a dent out of that, which is sad. And so we've talked about all this percent increase, percent decrease. It's not super duper interesting, if you ask me. But what may be super interesting is income tax. How are you taxed? And so let me not mince words here. Let me speak frankly to you. If you have a job in this country, if you are working in this country, you are likely paying income tax. And really, you're probably paying it in any country that you work in. No matter where you are almost certainly paying income tax. It's just a cut of how much money you're making that goes to the government. We're going to talk today about how income tax works. We're going to talk about how they tax you. We're going to dispel a lot of income tax myths because a lot of us have myths about how it works. A lot of us say, well, if I make $56,999, the government's going to tax me at 20%. But if I just make $1 more, if I make $57,000 a year, the government's going to jump up and tax me at 27%. No, that's not how income tax works. They don't just suddenly tax your entire income at a certain amount. They tax only the part of the income that falls into that new, they call it a bracket. So they're only going to tax that $1 extra you're making at that higher level. The rest gets taxed at the lower level. A lot of people have made arguments, well, then I'm not incentivized to work harder and make more money because I'm just going to get taxed more. No, only the extra money you're making is going to get taxed at a higher rate, but you're still going to keep the money that's not taxed. So you still end up with more money, period. So there are certain myths that we need to dispel about income tax. What is it? It's exactly what it sounds like. It's a tax on your income. It's a percentage of your income collected by the government to fund its services and programs. Now, we all have our feelings about taxes. I'm not going to share any of my beliefs whatsoever. I'm just going to share you the objective math and how it shapes up. I'm even going to use, this PowerPoint might be a little outdated. I'm going to use the most recent tax brackets that are going to be true for the 2020 tax year. Whenever we do some of these computations, because I want you to see a realistic computation here. So this is we're going to need to define a few things. We're going to need to define a few things. Let's see. You always end up paying tax. Well, that's interesting. Yeah. So you end up paying tax. What will happen is if you're an employee working and you get something called a W-2. Now, not every employee is a W-2 employee. You can be self-employed and you can be a 1040. These are all just fancy names for the different IRS forms and filing statuses you have. But most of us, if we just go work for a company and we're an employee, we get something called a W-2. And what they do with their W-2 employees, in almost every case, they take income tax out of your paycheck automatically. Why? So that later on in the year, you don't get hit with a giant tax bill. If you're self-employed, you're the one paying yourself. So if you choose not to take money out of your individual paychecks, you might be setting yourself up for a huge slap in the face tax bill because you owe the same amount of income tax. If you make $100,000 a year and you're self-employed, or if you make $100,000 a year and you are working for a company with a W-2, if you have the exact same tax setup, like same number of children, maybe same other things, tax credits, adjustments, you're going to owe the same amount of taxes. But the person who is the W-2 employee has had the money getting slowly taken out of their paycheck. So when it comes tax time, they may not owe anything. They might even get a refund. Yeah, so your parents file their taxes every quarter, I assume, right? That's cool. So I assume since he's self-employed, owns his own company, he probably, if you're self-employed, you're supposed to file your taxes every quarter, every 3 months. Yeah, and then you file for your entire year, but you've been putting aside every quarter. And they do that so that you know every quarter you should put some tax money aside. So when the big bill hits later in the year, you've already paid off some of it. So whenever you get a refund from the government, here's how it works. You're not actually getting new magical money you never had before. All it says is that, hey, we already took $10,000 out of your paychecks the entire year for income tax. But now it's time to sit down and calculate how much income tax you owe. And you actually only owe the government $8,000. Exactly. That's what your refund is. They're going to give you the $2,000 back because you've already overpaid the government so far. And that's something when I was younger, when I was 19, 20, I used to think a refund from the government was just the government giving me free money. That's not how it works. The government is giving you back money that you had already put aside, but you didn't need that much. And that's because your company doesn't know the exact amount you're going to end up needing to take out because your situation changes throughout the year, things like that. So your company will usually take out more than is necessary if you're at a certain income level. So tell yourself this, repeat it in your mind. When you get a refund from the government, you're not necessarily getting magical new money. You're getting back money you've already paid out. You're getting some back. Now, there are exceptions. You can get certain things called tax credits, which is where the government is directly paying you, things like that. We'll talk about the different types of credits as well. We probably won't finish this section today. That's okay. So all that aside, let's actually get down and get into the nitty-gritty of this. If you learn this stuff and you understand it well, you can do every legal action possible to lower your tax, the amount of money you have to pay the government in taxes. And it's all legal too. I'm not teaching you little tricks and little ways you can steal from the government. Not at all. I am teaching you how the actual tax system works and how you can pay the least amount of taxes and get the most back. The first thing you need to do is you need to calculate something called your adjusted gross income. You start with your gross income, and it's not gross as in gross. It's gross as in it's the total amount of money you made. How much did you make this year? Total. That's your gross income. You subtract off these things called adjustments. Now, there's certain types of adjustments. I'm going to bring up what they are real quick. Well, it's actually gotten a little bit more complicated, but there's certain things that you can subtract out from your gross income, which is good because when you subtract out adjustments, the government is going to say you're making less money than you really did, so we can only tax you at the lower amount. So the government lets you make certain adjustments and subtract it off what you're going to end up owing, in essence. This can include payment to tax-deferred savings plans. So there's certain savings plans out there, a standard IRA, not a Roth IRA, which is an individual retirement account. And what you can do is say you made 100 grand this year, but you put $5,000 into the retirement account, the special kind. Well, then the government says, okay, you made 100 grand, but we're going to subtract 5,000 from that. And we're going to say you only made 95 grand. You actually did make 100, but by saying you only made 95, they're going to tax you at a lower amount because they're going to see less income. That's what it means. So putting money into certain retirement funds is good because you pay less taxes on your income as a result. That's one example of an adjustment. Now, the next amount, you have to determine your taxable income. You have to determine your taxable income. You take your adjusted gross income that you found in step one. Usually that's abbreviated your AGI. And then you subtract off your exemptions. And if you distribute the minus, you also subtract off your deductions. So adjustments are one way you can lower your taxable income, which is exactly what it sounds like. It's the income the government's going to base for your taxes. You can take off money for exemptions. That usually is going to be in the form of dependents. If you have, usually that's children, but if you have maybe a brother who depends on your income, lives with you, if you have a parent, there's all kinds of different situations where you might have dependents. You get to take exemptions. Let's use updated numbers, 2020 exemptions amounts. Now, it's gotten a little bit more complicated because tax law changes year after year. But basically, the more you or the less you make, the more you're allowed to take out in exemptions. So for instance, let's say that you got $4,500 per exemption. So let's say you had 3 children living with you that you take care of. 4,500 times 3, shouldn't need a calculator for that, it's 13,500. You get to subtract 13,500 off of your income, off of your adjusted gross income, which is good. You still made that $13,500. That's not saying they're deleting that. Exactly. It's a money that you don't, well, you're telling the government, but you know what I mean. Exactly. The government doesn't look at that income. It ignores that income and you don't have to pay taxes on $13,500. You still have made that $13,500. It's still your money. But because you're taking care of children, the government's giving you a little bit of a break and saying, we're going to ignore $13,500 of your income. There's also things called deductions. A deduction is just another thing that the government lets you take out. Usually, unless you have a very unique tax situation, or really if you're spending a lot of money on very specific categories, usually you're going to take something called a standard deduction. And the standard deduction, in 2020, if you're filing as single, you're not filing with another person, your partner or whatever, you're filing as single, you get to deduct an additional $12,400 from your income. That's wild. It used to be a lot less, but they changed how deductions work to give people tax breaks. So yeah, you literally get to take $12,400 right out of your income. You still made that money. That's still your $12,400. This is just money the government is ignoring. So let's say it's simple: adjustments, exemptions, deductions. Good, all good. These are good things because they lower the amount of income the government's going to look at. Ultimately, what's going to happen is they're going to take your taxable income. It's your gross income minus all adjustments, and then minus any exemptions you have, and then minus any deductions you have as well. So that's your taxable income. So if you made, say, just to keep the numbers simple, if you made, say, 100 grand last year, but you have 3 children, you took the standard deduction, and you had a few adjustments. Let's say you had $25,000 in adjustments, exemptions, and deductions. So even though you made 100 grand last year, the government is going to ignore 25,000 of that. And the government is going to say, well, you only made $75,000 that we're going to tax you on. You're still going to declare all that. The government knows you really made 100 grand. But these are the rules. These are things you're allowed to use. None of this is lying or anything, weird. What is lying is telling the government you have 99 dependents. You have 99 children you're supporting and you don't have any. And I had a student tell me once that he had a coworker that every year would just lie to the government, tell the government he had 99 dependents when he filed his taxes, and he would end up not owing any income tax because the government said he had $0 in taxable income. In fact, he got money back. Nobody has 99 children that I know of. That's just kind of like a maximum number they put that you can fill out on a form. I have to imagine that person got caught. Here's what happens. What's that? There's no way that person got away with it in the long term. What happens, what the government's going to do is fun. Let's say that for the last 10 years, you've been lying to the government. So none of these are lies. Adjustments, exemptions, deductions are all legal and all above board, and you're allowed to use them. When you lie to the government, you could literally hide some of your money illegally and say, no, I didn't make this. You can lie and say you had 99 children every single year, something like that. Well, let's say for 10 years, you should have been paying the government $10,000 a year in taxes, but you lied and didn't pay anything. Well, 10 times 10,000, you owe the government $100,000 in back taxes when they finally catch you. Now, first of all, if they catch you lying and cheating and they can prove it was lying and cheating, they might just throw your butt in jail, like straight up, and make you pay that money back. If, however, if they can determine it was a mistake, you misinterpreted something, you only did it like 1 or 2 times and you didn't even realize it, something like that, and you were wrong on your taxes, they'll usually cut you a break and say, okay, all you gotta do is pay us back. But they're gonna make you pay them back with interest. And the longer you go without paying them back, the more interest they're gonna charge. There's a very famous, have you ever heard of the actor Wesley Snipes? He's cool. He was in the Blade movies. He was a vampire hunter who was half vampire and he had a sword and it was really cool. Yeah, his Wesley Snipes. He's a famous actor. He lied to the government for years about his taxes. He cheated the government for years. I mean, the man's a millionaire. He's a movie star and all that. And he lied and cheated about it for years. And the government caught him and they made him pay a ton of money in back taxes. I think he went to jail for it. He spent some time in prison for it. So yeah, don't lie to the government. If you want another case, if you've ever heard of Al Capone, the old Chicago mobster from like the early 1900s who was, making alcohol and selling it when alcohol was illegal during Prohibition and doing a lot of other stuff. He was a criminal. He ordered people to be murdered. He's a crime boss, exactly what you think. You know how the government stopped him? The government back then could not prove that he had committed any crimes himself because technically he was always just ordering other people under him to commit crimes. So yeah, he wasn't directly the one committing murder or stealing, things like that. He was just ordering it. So he's still clearly guilty of something, but the government couldn't put its finger on it. The government caught him for tax fraud. The government literally took down Al Capone because a bunch of accountants went over his books and went over his tax filings over the past however many years and realized that he shorted the government on taxes, and they arrested him and threw his butt in prison for taxes. That's how they brought down the great crime boss Al Capone. That's how serious the government is about keeping its money. If someone steals $100 from you, you might get mad, you might go punch them or something. If you steal money from the government has a lot more resources. And if you want one last little interesting piece, today, what Al Capone did is a crime that can be charged. It's called racketeering. And in the 70s, there was an act passed called Racketeering in Criminal Organizations or Corrupt Organizations called RICO. And that RICO Act, because it was passed, it allowed the FBI and other government police agencies to take out like crime bosses, mob bosses, even though they technically weren't committing the crimes themselves. It was called a conspiracy charge. Yeah, it would be conspiracy because it feels like something that you should get in trouble for. Exactly. You're still committing some kind of crime. So they called that racketeering. Mm-hmm. So she asked if someone wants to hide money from the government. She's trying to hide money from the government. She's trying to ask how she can do that. No, I'm kidding. If you wanted to, if a person in theory wanted to hide money from the government, that's not as easy to do as you think. She asked, could you just convert it all into cash? But by converting into cash, that implies it was once in an account somewhere, which means there's a digital record of it. The only so that's a real thing. Drug dealers hide their money all the time. Kind of. That's partially true. What a lot of drug dealers will do is they understand that if the government can't prove that they're dealing drugs, the government can't prove that through its usual police methods. Well, usually what the government will then do will say, hey, this drug dealer lives in a $2 million house and drives a Lamborghini, but said he made $15,000 last year. The government's not going to believe that. So they're going to pour over his tax stuff and they're going to try to bust him on that end. So, but drug dealers are not dumb. Criminals are not stupid. That's why it's not easy to handle crime. What drug dealers and other criminals of the type will do was they will start up these businesses, and these businesses might be legit on the surface. They might have a copy business where people can go make copies. They might have a coffee house. They might actually have owned property, like property that people pay rent on. They will have legitimate businesses, and they do what is called money laundering, where they wash their money through these businesses. They take the money that they may have earned from illegal activity, they use that money to buy legitimate businesses, and they will take their money from that and put it through the business, and it comes out clean, and they'll pay their taxes on it. And when the government's looking, exactly. So the quickest way for a criminal to get caught is to not pay their taxes. That's usually going to get you in trouble much faster than a true criminal investigation. But that is off the point a little bit, but it is kind of interesting stuff. Anywho, that's fun. I'm not just to preface, I'm not teaching you how to commit crimes. I'm very much against crime. I'm just telling you how hard it is sometimes for the government to stop crime. Because you might think, oh, shouldn't we just be harder on crime? That would shut it all down. And it's like, well, what does that mean specifically? It's not as easy as you think it is. It's a lot more difficult. So finally, the amount of income tax you're going to get. You're going to take your taxable income. They're going to figure out what you owe on that tax. Then they're going to subtract off if you got any tax credits. Sometimes the government will straight up give you an extra $1,000 for every child you have. Even though they've already given you an exemption for that child, they'll give you even more money. Now, the $4,500 exemption was not $4,500 the government gave you. It was just saying the government's going to ignore $4,500 of your income. But a tax credit is literally $1,000 the government's giving you. So if you do your tax computation and it turns out you overpaid by $2,000, and so you're going to get a $2,000 refund, well, actually you find out you got a $1,000 tax credit, you're now going to get a $3,000 refund. They're going to give you more money. So a tax credit is not the same as a deduction, adjustment, or exemption, because that comes in after the fact. Your parents can what do you call it? Declare you as an exemption, as a dependent, they'll call it. They can declare that if you're still living with them, or if you're more than like 50% reliant on their income, I think is the rule. Then yeah, you're still considered a dependent. They can declare you and get that exemption. But for you, if you're making money and you go file your own taxes, you have to declare yourself a dependent on someone else, and you're not going to get as nice of a tax break as they are for having you as their child. as their. So a lot of the times, if if you turn 18, 19, you move out and you live on your own and you're supporting yourself, you're going to want to declare yourself. You want to say you're not a dependent on anyone else, because that's going to improve your own personal tax situation. The person who was declaring doesn't get to declare you anymore, and so they're going to owe more taxes. But if they're not supporting you with their money, then they shouldn't get that benefit. So lots of things going through here. The truth is, the tax situation changes every year. So the standard deductions in the last couple of years, I'll say Trump, but what I really mean is the national government, Trump, whatever you want to call it, changed the way standard deductions worked. They pretty much wiped out certain adjustments, but instead they just said everyone could make a higher standard deduction. So only like 3 or 4 years ago, the standard deduction was about $5,950 or $6,000. Now it's somewhere around $12,000 to $13,000 for an individual filer. So some of these numbers are going to be a little outdated, and that's just because the tax law is changing every year. So what I'm doing is I'm trying to give you an overarching idea of how taxes work, and you'll just have to know, well, the tax law is changing, so these general concepts are true, but some of the specific numbers are going to change over the years. So let's compute someone's taxable income. So remember, taxable income is what the government's really looking at to tax you on. So a single man earned $4,650 last year from a savings account. Or excuse me, just earned $46,500 just in his regular income from working. He received $1,850 in interest from a savings account. Somehow won $15,000 on a TV game show, so that's cool. But guess what? That 15 grand isn't really 15 grand, because you got to include that 15 grand in your as income, and thus you got to pay taxes on it. So that 15 grand may only feel like 12 or 11,000 depending on how you're taxed. Anywho, the man also contributed, so $2,300 left him he put it into a tax deferred savings plan. He's entitled to a personal exemption of $3,800. So that's actually what the government changed. Only a couple years ago, you got an exemption for yourself. Even if you had no kids, you still got one exemption. Now they just kind of wrap that up into the standard deduction. So that's why the standard deduction's higher. You still get exemptions for your kids though. But for your own personal exemption, they don't separate it like that anymore. And it's really just 6 of one, half dozen of another. The man gets to the interest on his home mortgage was $6,500. He paid $2,100 in property taxes and $1,855 in state taxes. He also contributed $3 grand to charity. So we've got a lot to break down here. And all we're doing is calculating his taxable income. We're not calculating how much he's going to owe in taxes yet. So first of all, determine the man's gross income. Well, he made $46,500 in wages. He got $1,850 in interest from a savings account. That's going to count as income. So yes, when your investments earn money, when your savings account earn money, you got to pay taxes on the amount that is earned in most cases. And then he got an extra 15 grand on a TV game show. And so the man's total income was $63,350. Now his adjusted gross income, the only thing in here that was considered an adjustment was the $2,300 he put towards a savings plan, a tax-deferred savings plan. And when it says tax-deferred, it literally means you're paying taxes on it later on. So you don't have to pay taxes on it now. Thus, you get to subtract it from your income. The government knows you actually made $63,350. It's not stupid. It's just saying we're ignoring certain parts of it when it comes time to tax you. So his AGI, his adjusted gross income, was $61,050. The man's taxable income, we take his AGI, and we're going to end up subtracting all deductions and all exemptions. So we're going to add up all of those kinds of things. So The taxpayer is entitled to a personal exemption of, well, the numbers changed all of a sudden. Oh, the numbers completely changed. That's weird. Let's go back and change this. Sorry, I don't know why they say one thing and another. Standard deduction is 6,300. Okay, so the man gets a personal exemption of $4,050, a standard deduction of $6,300. Now, what's going to happen is you can either take the standard deduction or you can itemize your deductions. What that means is things that would count as deductions, if you add them all up and they're more than the standard deduction, you can use that. However, if you add them all up and they're less than the standard deduction, you can just use the standard deduction. So the only deduction the man can take is $6,500 for his home mortgage. If he took the standard deduction, he'd only get to take out $6,300. But instead, he's going to do $6,500. He's going to itemize his deductions. He also paid $2,100 in property taxes and $1,855 in state taxes. He also contributed $3,000 to charity. All of these things are going to count as either deductions or exemptions. So we're going to add up all this business. We also need to add in the personal exemption. I guess they didn't add it in here because they took away the personal exemption. So this thing is not coming in consistently. But using the old school numbers, the man gets to deduct or exempt a total of $17,505 from his income. So we take his AGI, the $61,050, and we subtract off $17,505 in total. They just added their exemptions and deductions together. So I guess maybe technically we don't have to do it here. They did it here. So in total, the man got to take off. So the man's taxable income is only going to be $43,545. The government knows that he made $63,350. The government only cares about $43,545 of it. And we'll talk about the rest of this next time. So remember, you have an exam that's coming up this Thursday. You can take it anytime on Thursday. You're going to take it in MyLabs Plus. You're going to use the, what do you call it? The HonorLock browser thing to take it. It's over chapters 1, 2, and 3. Y'all have a lovely day. And again, so that means we won't be meeting on Thursday at all, Zoom or in person, because of the exam.